Oh, hi, welcome everyone to the last session of the web and mobile track. So our last speaker is Ms. Jyotsna Gupta from Visa. She's a staff software engineer here, and today she'll be sharing with us about the Go compiler. So without further ado, it's a 15-minute talk. Right, so let's pass the time over to her.
Hello. Yeah, thank you everyone for joining today. And I'm Jyotsna, and I'm really excited to be here to talk about something that often feels like that it's a black box, right? That is Go compiler. So, but before diving in, I'll just share a bit about myself. So I'm Jyotsna again, as mentioned, and I currently work as a staff software engineer at Visa, and I've been working in payments industry for a while, and prior to that I worked at Gojek as a senior software engineer, and I have been working in Golang for the past 6 to 7 years of experience. And apart from work, you will find me running communities or playing badminton or etc. So I run Women Who Go Bangalore chapter in Bangalore. So, and apart from, so if you see the right hand side, these are my current positions or achievements or whatever I'm contributing towards, and that's that side, it's my past contributions or involvement with the community side. Yeah, that's all about me, and let's start. So I just, I'll take a pause here. I just want to understand how many have you used this Go build tool ever? Anyone? Okay, I see 4, 5 hands here. So yeah, it looks like 4 to 5 people have already been aware with Golang or used any language, any program, written any program in Golang. So it's a very powerful tool, but for us as a developer, especially when we are fresher, right, we just use this tool and it looks like that, okay, you write the code and then hit this command and finally you find the executable, right? But actually it's not a direct process. It involves a lot of multi-steps, and I'll share what are those steps in detail today. So if you see, these are the steps, multi-level steps, and there are a lot of steps. I'll get, it might be overwhelming in the starting, but later on I'll finally summarize this. So initially it starts with how you enter the source code input, right? So basically you have written the code base and you hit go build command, right? And finally the compiler reads your source code file, and the first step would be the lexer phase. This is the phase. So that's the first step. Here what happens, every command, every sentence in your Go code is actually being broken down into smallest unit of meaning, which is token. So you can say, for example, if it's a hello world program, right? So you have package, main. So Go is actually breaking down in these keywords. Keywords could be identifiers, variable name, etc., function name, it could be operators, etc. And here at this stage, discarding of the white space and comments also happens. So I hope you are clear with this stage. So this is also called as scanner phase. So once the lexer converts your code into tokens, it gets passed to the input to the parser. So parser has the input of the stream of tokens which were actually converted into the phase of lexer, and it ultimately creates or constructs a tree-like structure, which is abstract syntax tree, AST, which is the output of the parser ultimately. So once parser gets involved, so it will get a stream of tokens, and then finally result output is a tree-like structure. Basically it's a grammatical structure of the code. So at this stage it also checks whether your code is actually aligning with the grammatical rules of your language or not. Language by here it means Golang. So it is actually checking if whether your code is structured properly in terms of grammatical issues or not. So once this phase is over, next phase is type checking and semantic analysis. In the semantic analysis, what happens is your code base gets your code base has the input of AST right now, and it gets into the semantic analysis phase, and finally it actually checks whether your code base, the tokens actually AST, is actually sticking adhered to the semantic rules of the language or not. So this is what it looks like, and here at this stage, type checking or type mismatching, constraints, scoping rules, all these things are being checked, and ultimately it checks, ensures the operations are performed on the compatible types like type mismatch. So for example, it ensures that you are not using an integer as a function. So if you have used, the compiler will actually halt there, and it will actually showcase that you are using a wrong integer. And the next steps after the semantic analysis phase is the generation of the intermediate representation. So at this stage, what happens is you have already checked the semantic analysis, syntax analysis, and so what happens, it translates the AST into the series of instruction set, which are actually being passed to the next phases. And it is independent of the machine target, like your target machine's architecture, so it doesn't care about much, but it acts as a middle ground where a lot of optimizations can actually happen. So you might be aware that Go compiler is quite fast. So how does it, so the optimization is very, very much important here at this stage, and this is why this stage is very much important, because it helps in optimization. So once this is done, and this is a lower level representation of your code, but it is not actually machine level code, but it is quite close to the high level, it is close to your machine, but not that like high level code. And as I was talking about optimization, so intermediate representation is the phase which helps the compiler in optimizing the code base. So there are a lot of techniques through which we can optimize the code. One of the methods is SSA, that is static single assignment, where basically each variable is assigned just once. So this ensures that your code is more optimized and a lot of dependency is deprecated here, like it's avoided. And next is it generates the machine code. So what happens in this phase, you have already achieved all the phases, syntax analysis, semantic analysis, and then finally we come to the machine code generation part, where machine codes actually get generated, which is basically what your processor will understand, right? So binary instruction that processor can execute, and it actually maps the series of all the set of instruction set to the machine code instruction set, and it takes in account to the specifics of your target machine's architecture. So previously it wasn't the case like in intermediate representation, but it is the case here. So this ensures that your code is specifically running on your target machine architecture, like it considers like types or numbers of registers, etc. And next is linking machine code with the library. So this is the final step in the code compilation phase. And here what happens, linking actually resolves the differences to the different type of files or different type of variables which are present in the different files or libraries. So ultimately, linking will help in achieving everything will be there in your single binary, and hence executable will be actually created, and that could be actually processed or taken into considered by your processor, and so that your CPU can execute that executable, and hence it will run the program. So if you see this, if this is the summary of your compilation, so it starts with a source code input, but actually Go build tool is doing all these phases, and it goes through all these phases till the executable is ready, and this happens in within a second, right? Sometimes within milliseconds, or it depends on the code size. I wanted to give you a slightly overview of how it looks in the Golang, but since we are time constrained, so I'll just give you a slight overview. So you can just see a lot of things are already built in the compiler, like log statements, panic visualization of your logs, etc. If you run these commands, I really wanted to show these things hands-on, but since it was a 15-minute talk, so I wanted to avoid it. So if you run these commands, if you are curious enough to go back and try these commands, you will see a lot of things like how is SSA file, HTML file is generated for function foo. You can see print assembly, you can see the compiler phases timing through these commands. You can get the talk slides later after the words. And a lot of other helpful tools are also, I've tried using it. And one of them is benchmark. And compile bench, so it benchmarks the compilation phase for the compiler speed basically, and bench state. So you can go through these tools which would be helpful in the whole compilation, if you want to deep dive into the compiler, Go compiler. And I try to get into the details of the Go compiler through these, like source code is the actual source for everything if you really want to check. So if you want to check how lexer parsing is happening, there are a lot of switch cases which are happening. It checks is equal to, everything is in the source code. So I have listed the directories where you can actually find where AST is getting constructed or lexer parsing is happening. So you can go to the directories directly. And these are the slides resources which when I was reading about Go compiler, I found it very much helpful, and you can go through them whenever you get a chance. And that's all from my end. And thank you so much for attending on a Saturday evening. I hope you enjoyed this talk, and I hope it ignites some curiosity in you so that you can try those commands whenever you get a chance to try them. Yeah, thank you so much, everyone, for attending my talk.
Thank you very much. We actually have a little time. Is there any question for the speaker? No? Okay, if not, also feel free to engage. Oh, okay.
Where would Go be faster than, let's just say, like okay, I think the fastest JIT compiled one would be Lua, like some version of Lua JIT. Is there like an optimal kind of use case for Go in terms of getting speed, but you're still kind of got a garbage collected kind of fast kind of development?
Can you rephrase? Like, I could understand a bit, but not complete question.
Where would you say is the best use case for Go in terms of where it kind of takes advantage most of its speed without there'll be some kind of numerical things where it probably doesn't take full. It's not designed for that, so it's not designed. It doesn't benefit, or it's not designed to there'll be some kind of there'll be a C application where it needs the speed. But where would you say Go's niche?
Okay, understood. Thanks for asking this question. So basically what happens, for example, C, you talked about C, right? C doesn't have garbage collection. So in Go, it's already being inbuilt. So it already helps a lot of things which a newbie doesn't want to spend a lot of time on, right? So if you work on Rust, let's say, or C, you will need to first work on those parts, write those things from scratch, which I don't need to write if I am using Go. So for example, you might have heard about TypeScripting. They have recently written everything in Golang recently, 2, 3, 4 days back, and they choose Go because of the same reason. A lot of things were actually helping them in similar scenarios. And if you kind of ask me about the use case, so Go is really popularly known for its concurrency, right? So are places where a lot of concurrent scenarios are happening. For example, streaming is happening. Prime Video is there. You are watching something, Netflix. So there, Go concurrently, you are using a lot of concurrency principles. So there, Go will be very much helpful. And if you have to talk about with Java, So Java, if you compare, so sometimes it might be similar to what Java is providing, the same efficiency, but it really depends on your code, and you need to actually benchmark them. So that's what also TypeScript did recently, and they have written a whole blog about why they chose Golang over Rust, because they benchmarked the things and it worked for their own purpose. Yeah, I think I was able to answer your question. Yeah, thanks.
Okay, thanks very much. So this will end the sessions for this room. And everyone is invited, of course, to the closing ceremony. It will happen in the main hall. Yeah, so please feel free to make your way there. Or of course, if you need to engage with Ms. Jyotsna, please feel free also. Yeah, so see you around in the main hall. Right?
Thank you, everyone. Thank you.
Thank you.